Hello, math students. Welcome back to our module called Area, Surface Area, and Volume Problems. This is lesson 2, and it is called Polygons on the Coordinate Plane. The goal for today is we will learn how to determine side lengths of points on a coordinate plane. The question that I want you to think about is, how do you plot ordered pairs on a coordinate plane? All right, so we're going to do some practice because this is a little bit of a review. You are familiar with a coordinate plane, and a coordinate plane is where you have a horizontal line that intersects with a vertical line. The horizontal line is called the x-axis, as you can see right there, and the vertical line is called a y-axis, which you can see right there. And basically what a coordinate plane is it's a representation of all of the points that are on this graph. Okay, this right here is quadrant 1. This one is quadrant 2, quadrant 3, and quadrant 4. And we actually label those using Roman numerals. So again, this is quadrant 1 right here. This one is quadrant 2. This one is quadrant 3. And this one is quadrant 4. Okay, so there are 4 quadrants in a coordinate plane. And then what we need to remember is that if you are plotting points that are in quadrant 1, the values of the numbers are going to be positive in both of your coordinates. So the x value is going to be positive and the y value is going to be positive because we're talking about all numbers to the right of 0 and all numbers up from 0. So those would be both positive. If you go into quadrant 2, now we're talking about all numbers to the left of 0, which happen to be negative. So the x value is going to be negative. However, the y value will still be positive because we're going up from 0. So in quadrant 2, all of your values will be negative, positive. And in quadrant 3, since we're going to the left of 0 and down from 0, all of your coordinates will be negative. Okay. And then in quadrant 4, we are back into working with all numbers to the right of 0, so they're positive again, but we're working down from 0, so those are negative. So that's how you need to remember the ordered pairs and where they live. Positive, positive in quadrant 1, negative, positive in quadrant 2, negative, negative in quadrant 3, and positive, negative in quadrant 4. Okay, so those are just little reminders that we've talked about before. And then what you have to do, however, is you have to know these things so that you can figure out what is the length of segments. Because if you remember, our goal for today was we will learn how to determine side lengths of points on a coordinate plane. And so what we have to do is we have to figure out what is the distance. Okay, so it says let's practice. Use absolute value to find the lengths of the segments. And if you remember what absolute value is, just another review of everything that we've learned, absolute value means the number of hops from 0. So we have to figure out how long it is, and then we've got to take that and count the number of hops from 0. So the first one is done for us. If we look at it, it says line segment AB. Line segment AB is right here. So here's A and here's B. We're talking about the distance from A to B right there on the graph. And so first thing you have to do is you have to plot the 2 points. So if we look at what A is, we went to the left 1, 2, 3, 4, and then we went up 1, 2, 3, 4, 5, 6, 7, 8. So the point for letter A is -4, 8. And then B is in quadrant 1, so they're both positive. So we went to the right 2 and up 8. So that's how we got to 2, 8. And then what we have to do is we have to figure out the distance. And the way we figure out the distance is we look at our coordinates. If our coordinates share one in common, then all we have to do is count. And look, on this one, they do share a coordinate, and the coordinate that they share is 8. So since they share a coordinate of 8, all we have to do is start on one side or the other and count to the other side. So if we do that, let's start at A, and we're going 1, 2, 3, 4, 5, 6. So we know the distance is 6. Then there is a mathematical way to prove it, and the mathematical way to prove it is to use the absolute value to find the lengths of the segments. So remember, absolute value is the distance from 0. So I know this is 0 right here, right? So if I was going to where A is, then I would know the distance from here to right here. And that, if you count, is 1, 2, 3, 4. So that's how we got the absolute value of -4. And the reason why it has to be -4 is because we went to the left of 0. And then we're subtracting the distance from 0 on this side. So we went 1, 2. So that would be the absolute value of 2. And so this says that you are taking the absolute values of your numbers and then you are figuring out the distance. And so what we have is 4 plus 2 equals 6. And so that's what we have to find our distance right there. Okay? So that was pretty simple, yeah? All right, now let's try the next one. See if we can get it. I'm going to change colors. Okay, so now we're doing BC. Well, BC sits right here. Here's B, right? And here's C. So we do the exact same thing. We have to label the points first. So we're going, B we already know is 2, 8. All right, and then we have to figure out C, which is 1, 2, 3, 4, 5, 6 to the right, up 8. So this would be 6, 8. All right, and now we know because they share the 8 still, 8 and 8, that now all I have to do is count it. So if I count from here to here, I get 1, 2, 3, 4. I get a distance of 4. And now I can use absolute value to figure that out. B has an absolute value of 2 plus C has an absolute value of, from there, it would be the absolute value of 6. And what we have to do on this one is we actually have to find the distance in between. So this is actually going to be minus, and so we get a distance of 4 because 6 minus 2 is 4. Okay, so that is another way to help you solve that one. Okay, and now let's try another one. And the other one says A, C. So you're actually going from here to here. Okay, so A was -4, 8, and C was 6, 8. Again, they have the 8 in common, right? So 8 in common. So all we have to do is count. So we know that this is 4, and we know that this is 6. So if we count them, then we would get, starting at A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We would get a distance of 10. And so we have the absolute value of -4 and the absolute value of 6, which gives us a distance of 10. Okay, so that's very, very helpful in figuring that out. Okay, now we're working on C, and C is 6, 8, 6, 8, and then D, D is down here, and D is at 1, 2, 3, 4, 5, 6, so over 6, except down this time, 1, 2, 3, so it would be -3. So we're looking at this distance. So from C to D, which is here, right? So now all we have to do is the points that they share this time are the 6's, right? So they have 6 in common. So now all we have to do is count the distance from those two. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So on this one, we have 11 is the distance. So we are taking the absolute value of 8, and we're taking the absolute value of -3, and when we add those together, it gives us a distance of 11. Okay, so now we're going to do D to E. Okay, so D is, let's go with D is 6, -3, right? And then E is 6, -1, 2, 3, 4, 5, 6, -6. All right, so they share the 6's. So now all I have to do is count the distance between these two. So I get 1, 2, 3. And so this one has a distance of 3. So we're taking the absolute value of negative 3, and we're taking the absolute value of negative 6, and we are subtracting those, and we get a distance of 3, because we just want the distance in between those 2 points, right? So that was D to E. What is the distance? Okay? And then our last one is E to F. So our last one is E to F, and we know that E is 6, negative 3, and we know that F is 1, 2, 3, 4, 5, 6, 7, 8, so that was negative 8, comma, oh wait, that was a negative 3, that was negative 6, I'm sorry, negative 6, that's my fault, okay. So 1, 2, 3, 4, 5, 6, down 6, right? So I went to the right 6 and down 6 for E, and then I went to the left 8 and down 6 for F, and that's how I got to F. So we're talking about the distance along here. And then we have the negative 6 in common. So now all I have to do is I have to count the distance between the two. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I got the distance of 14. So I'm taking the absolute value of 6 and the absolute value of negative 8, and I'm adding them together, and I got 14. Okay? All right. So that was pretty easy and pretty helpful, yeah? So basically, whenever you're just finding the side lengths, you have to find your two coordinates, find what they have in common, and then count the distance between the differences that you are given, okay? So it's really important to know how to plot ordered pairs, okay? Very, very important. And then just determining the distances is the amount of space in between the two lines, okay? To find the distance between 2 points, you must subtract the two coordinates that are not the same. And when you're subtracting them, you just have to make sure that you're trying to find what is the distance between here and here. So sometimes you subtract, sometimes you add, depending on how you set up the problem, okay? So our goal for today we will learn how to determine side lengths of points on a coordinate plane, which we did. And the question that I wanted you to be thinking about was, how do you plot ordered pairs on a coordinate plane? Basically, the way that you plot them is you know where the types of points live. So positive and positive live in quadrant 1, negative, positive live in quadrant 2, negative and negative live in quadrant 3, and positive, negative live in quadrant 4. And once you remember where those all live, then you can put them where they're supposed to be, and then you can find the distance between them. All right, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye.